Hello, algebra. So this is lesson 3.2, linear functions. Our essential question is, how do you identify linear functions and graph them? So a linear function is an equation in two variables, x and y. It can be written as y equals mx plus b. A linear function is a function whose graph is a non-vertical line. It has a constant rate of change, okay? So it's a straight non-vertical line, straight line. So when we're looking at our first three right here, our first one, this is not a straight line. We can't use a ruler to make it. So this is a non-linear function. All right, non-linear function. And we know it's a non-linear function because if I do my vertical line test, it passes. So it is a function, but it's a non-linear function. For our next one here, can I use a ruler to draw this straight non-vertical line? Yes. So this is a linear function. And then for our next one, this one's a little tricky for most students. It is a function. It passes the vertical line test, but can I use a ruler to draw it? No, I can't. So this is a non-linear function. All right, it's a non-linear function. So then when we come down here, let's say we have tables instead of graphs. So the first thing we need to ask ourselves, is there a constant change in x? Is there a constant change in x? Well, I go from 3 to 6, I'm adding 3. When I go from 6 to 9, I'm adding 3. When I go from 9 to 12, I'm adding 3. So is there a constant change? Yes. We're adding 3 each time, constantly. The next question, is the first difference in y constant? We're going to get into second difference and stuff like that when we do later units. So really, I'm just asking, is it constant the way that we're changing our y's? Well, we're going from 6 to 30, so I subtract 6. Then we're going from 30 to 24, subtract 6, then 24 to 18, subtract 6. Is that constant? Yes. We subtract 6 each time. Well, if I said yes to both, that means that this is a linear function. All right, so this is a linear function. So now let's look over here. Do we have a constant change in x? Well, I'm going from 1 to 3, so that's plus 2. Then 3 to 5, plus 2. Then 5 to 7, plus 2. So yes, we add 2 each time. Is the difference in y constant? Well, I'm going from 2 to 9, so that's plus 7. Then 9 to 20 is plus 11. Then 20 to 35 is 15. Is that constant? No. It's not constant. So if no to just 1, it's a non-linear function. All right, it's a non-linear function. So there are 2 others that I want you to check out on this page up here. Take a minute, decide if they are linear functions or non-linear functions. All right, for this one right here, you should have gotten it's linear. You're increasing your x by 1 and your y by 2. Yes to both. Linear function. For this one, you're increasing x by 1 and y is decreasing from 16 to 8, so that's minus 8, then minus 4, then minus 2. Not constant, non-linear function. And like I said, we'll get into exactly what that looks like in other units. But just for now, we need to recognize non-linear function. All right, so how do I identify this when we use our y equals mx plus b? How can we identify and represent linear functions? Well, for this one, this y equals 3.8, we can actually write in 0x, right? 0 times x is 0. 0 plus 3.8 is going to be 3.8. So I can rewrite this to look like y equals mx plus b. So this is a linear function. For this one, we can't have an x inside that square root and have it be a linear function. It's a function, but not a linear one. So this is a non-linear function. So for our next one, we can't have x be an exponent and have it be linear. So another non-linear function. For y equals 2 divided by x, x cannot be in the denominator for it to be linear. So another non-linear function. For this one, let's really have, if we distribute that 6, we get y equals 6x minus 6. That is a linear function. So this one is another linear function. And then over here, we have an x squared. X cannot have an exponent to be a linear function. So this is a non-linear function. All right, the next thing we want to talk about is things that are discrete and continuous. So it's going back to that domain and range. We have scenarios in life where we can only have whole numbers of things, right? Where only certain numbers will work. So, for example, the number of whole bowls of cereal that you've eaten, or the number of bags of flour that you bought before COVID really hit, or the number of tickets sold to a movie theater, or the number of frogs that got lost from, the biology classroom, or the number of shoes that were donated, or the number of books that you've read, things that we have to have in whole amounts, right? The number of cans of soda you've drunk. Things that we have to have in whole amounts. So we would have that on our graph here, like the integers. Integers are whole numbers, from 2 to 6. So 2, 3, 4, 5, 6. I've just got those dots right there, right? Just those points. That's it. Things that are continuous are things that we can have any amount of. So like the amount of time taken to run a race, or the height of a growing tree, or the length of COVID hair before hair salons opened up. So all numbers between 2 and 6. So it would have something that looks like this for continuous. So let's take a look at how we would use that, okay? How we would use that when we graph and what it would look like. So for this one right here, we have a linear function, m equals 50 minus 9d represents the amount m in dollars of money you have after buying d DVDs. So our domain is going to be the DVDs we purchase. That's what we have control over. And then the money that we have left is what we get out of it, basically, right? So we need to figure out, well, what's the independent variable? What do I have control over? I have control over the DVDs I purchase. So I'm going to put that down here on my x-axis. I could purchase 0 if I wanted to, and then 1, 2, 3, 4, 5, 6, right? And then that means the dependent variable is the money I have left over. How much I have left depends on how many DVDs I buy. And yes, I like DVDs. I'm old like that. But I remember like 8-track and VHS, so I'm pretty old. All right, is it discrete or continuous? Well, think about this. Can I buy a half a DVD? No store is going to sell me half a DVD. So I can't buy it, which means this is discrete. It's not going to be continuous. I can't have any amount. I can only have certain amounts, so it's discrete. So we want to find our domain and range. So down here, I am going to start with 0. Let's say I don't buy any DVDs at the store. I just look. And then what if I just buy 1, and then 2, 3, 4, 5, and 6? So that's going to be my domain. And we want to see what we actually get out of this. So if I plug in my 0, I end up with 50 minus 9 times 0. Well, that's just 0. Oops. Sorry, guys. So that will give me 50. And then if I do 50 minus 9 times 1, that'd be 41. And then you can see every time I'm going down by 9. So I'm plugging in whatever my input is and seeing what I get out. And then I get all the way down here. After I bought 6 DVDs, I have -4. Well, wait a second. -4? Can I actually buy that DVD? No. The store won't sell to me if I don't have the money. Okay, I'm just telling you right now, like that's a thing. The store won't sell to you if you don't have the money. Okay, so just know it. Agree with it. So that means when I go to plot these points, I'm going to have a 0 and 50 for one, 1 and 41 for another, 2 and 32, 3 and 23, 4 and 14, and then 5 and 5. And I cannot plot that, right? I can't actually have that happen. I can't have negative amounts of money. So up here, when I start looking at my domain and my range, I know that my domain is going to be 0, 2, 3, 4, and 5. 6 does not work. 6 is not accurate. I can't do that. I can't actually have 6. The amount I could have left would be 50, 41, 32, 23, 14, and 5. So I'm going to plot that 0 and 50. 1 and 41 is going to be right about there. 2 and 32 is going to be right about there. 3 and 23 is going to be right about there. 4 and 14 is going to be there. Some of my numbers are missing, but I counted by 5s. 5, 10, 15, 20, 25, 30. And then 5 and 5 is going to be right here. Am I going to draw a line to connect those? No, because I can't have a half a DVD. I can't. So I'm not going to draw a line to connect them. So I want you to try out this one on your own. Okay, this one is a 20-gallon bathtub, is draining at a rate of 2.5 gallons per minute. 2.5 gallons per minute. So we want the number of G gallons as a function of M minutes. So we've got G gallons. We know it's a 20-gallon bathtub and it's draining. So are we increasing how much or are we decreasing? We're decreasing by 2.5 gallons per minute. So every minute I've lost that much. So this is the equation you want to use, all right? And think about this one. Sometimes it's easiest to ask this first. Can I have a half a gallon? Can I have a quarter of a gallon? Can I have just a drop? Yes. So is it discrete or continuous? It should be continuous. So take a minute, pause the video, try this out, find your domain, find your range. I'm going to give you a hint. You're going to have greater than or equal to's for these. All right. And you will want to use your table down here. So try it out. All right, let's take a look at the answer really quick. So this is the wrong one. There we go. There's our bathtub. So you should have minutes for your domain. It should be between 0 and 8, right? 0 and 8 minutes. And then you should have between 0 and 20 for the number of gallons, because 20 is the highest and 0 is the lowest. You can't have more or less. Your independent variable is the minutes that have gone by, right? You have control over stopping, putting a plug in the bathtub and measuring and everything. So that's what you have control over, is the minutes. And then the dependent is how many gallons there are left. How many minutes have gone by affects how many gallons are left. So it is continuous. So down here we can see our graph, or our chart, I should say. We've got 0, 1, 2, 3, 4. So our output would be 20, 17.5, 15, 12.5, 10, and we would keep going, right? So then we would be down at 7.5, then 5, then 2.5, then 0. So we can see that right here. I've got my plots pointed, and I did connect it with a line because I can have anything in between, right? I can have a half a minute. I can have a second just go by, and I can measure. So I hope that this was helpful. Please email me if you have questions. Skills Practice is posted.